Right, today we're going to decode the absolute fundamental language of automation, PLC inputs and outputs. You can think of it as the secret conversation that's always happening between the digital brain and the physical body of pretty much every factory, power plant, and robot out there. I mean, have you ever really thought about it? How do these massive factories or complex robotic systems work without someone constantly pulling levers? It kind of seems like magic, right? This complex dance of machines all moving in perfect time. But you know what? It's not magic at all. It's a really elegant, logical system. And I promise, by the end of this, you're going to get exactly how it all ticks. So, right at the heart of everything is this little box, the Programmable Logic Controller, or PLC for short. The best way to think about it is as the dedicated, super reliable brain of the whole operation. And look, this isn't like your desktop PC at home. This brain is built tough. It's designed to live on a factory floor, with all the heat, the dust, the vibrations, and just run 24/7 without ever complaining. This is the thing that does all the thinking. Okay, so here's how we're going to tackle this. First, we'll look at the PLC's main job, the automation brain. Then we'll get into how it senses the real world and how it controls the machine. After that, we'll put it all together with a real example. And finally, we'll talk about why this is so important for technicians out in the field. All right, let's jump into section 1, the automation brain. Before we really get into the nitty-gritty of inputs and outputs, we need to understand what this brain is actually doing. What's its core job? It all comes down to this really simple but incredibly powerful loop. First, it senses what's happening out in the world through its inputs. Next, it thinks. It takes that information, runs it through the program we've given it, and makes a decision. And this happens ridiculously fast, thousands of times a second. And finally, it acts. It sends a command out to the world through its outputs. Sense, think, act. That's the whole game, right there. Okay, on to section 2, sensing the real world. So if the PLC is the brain, then you can think of the inputs as its senses. Its eyes, its ears, its sense of touch. They are the pathways that bring information from the messy physical world into the clean, digital logic of the PLC. So what do these senses actually look like? Well, there are all sorts of devices. You've got simple push buttons, which basically tell the PLC, hey, an operator wants to start the machine. You've got photoelectric sensors, which are like a pair of eyes, using a little beam of light to see if a box is in the right spot. And you've got things like temperature and pressure switches that give the system a way to feel its environment. All of these things are just constantly feeding data back to the brain about what's going on. Now, here's a really key concept. The PLC senses things in two totally different ways. On one side, you have digital inputs. These are super simple. They just answer a yes or no question. Is the button pushed? Yes or no. Is the box there? Yes or no. Then on the other side, you have analog inputs. These answer the question how much. It's not just is it hot, it's what is the exact temperature. It's not just is there liquid in the tank, it's how full is the tank exactly. So let's drill down on digital for a second. A digital input is literally the simplest piece of information you can get. It's binary. It's on or it's off. True or false. 1 or 0. There's absolutely no in between. The best way to think about it? A simple light switch. It's either on or it's off. That's it. But sometimes on or off just isn't enough. For more complex control, you need analog inputs. They give you the nuance, the detail. It's not enough to know if a heater is on, right? The PLC needs to know the exact temperature so it can keep it just right. That's what an analog signal does. It gives you a specific value from a whole range of possibilities, usually by sending a signal that varies, like a voltage between 0 and 10 volts, giving the PLC a super precise measurement to work with. Okay, so the PLC has used its senses, the inputs, to figure out what's going on. So now what? Well, now it has to do something. It has to act. And that brings us right to section 3, controlling the machine. And you guessed it, if the inputs are the senses, then the outputs are the muscles. This is how the brain makes things happen. And these muscles are all the devices that do the actual physical work. The PLC makes the decision, and then it uses an output to, say, fire up a motor starter and get a conveyor belt running. Or maybe it opens a solenoid valve to let some liquid flow. Or it could be as simple as just turning on a green light to tell an operator everything is good to go. The outputs are where the PLC's digital thoughts become a real-world action. And hey, just like the inputs, outputs come in those same two flavors, digital and analog. A digital output is that straightforward, simple command. Turn the motor on, full power, go. But an analog output, that's where you get the finesse.
It doesn't just turn the motor on, it tells it exactly how fast it should be running, sending a variable signal to control its speed anywhere from, say, 0 all the way up to 100%. Okay, we've talked about the senses, we've talked about the muscles. Now for the really fun part, the aha moment. Let's put this all together and see how it actually works in a simple, real-world example. I want you to picture a basic packaging line. You've got boxes just moving along on a conveyor belt, and our job is simple. We need to stop each box at the perfect spot and then push it off to the side to get filled. Pretty straightforward, right? So check out how perfectly this shows our loop. First, sense. A little photoelectric sensor, which is our input, sees the box get into position and it sends an on signal to the PLC. Second, think. The PLC's program sees that on signal and basically says, aha, the box is here, time to do my job. And third, act. The PLC sends a signal to an output, which turns on a pneumatic cylinder. That's just a piston that uses compressed air, and poof, it pushes the box off the line. Sense, think, act. That's the loop happening right there. Okay, so you might be thinking, this is cool, but why does this distinction between inputs and outputs matter so much? Well, here's why. Because in the real world, things break. They just do. And when they do, knowing this is your #1 most powerful troubleshooting tool. Think about it. When that conveyor belt just stops dead, the technician who shows up has a puzzle to solve. Is the problem the sensor? Did it just not see the box? Or is there a problem in the PLC's program? Or maybe the cylinder itself is busted. You've got to figure out where the breakdown happened. And here's how they do it. They start by checking the I/O, the inputs and outputs. See, most PLCs have these handy little status lights right on them for this exact purpose. So you look. Is the little light for the sensor input turning on when the box arrives? If yes, great. That means the PLC is seeing the sensor. Okay, next step. Is the output light for the cylinder turning on? If yes, great. That means the PLC is telling the cylinder to move. So, if both of those lights are working, but the cylinder isn't moving, well, the problem isn't the sensor, and it's not the PLC. It has to be the cylinder itself, or its wiring. Just like that, you've narrowed down the problem in a matter of seconds. This quote just nails it perfectly. Inputs allow the PLC to observe the state of the process. Outputs allow the PLC to control machines and devices. It's that simple. Inputs are for watching, outputs are for doing. And that fundamental split is what allows a little computer brain to control these huge, complicated physical machines. And seriously, don't underestimate how powerful this concept is. This closed-loop system, this whole sense, think, act thing, it isn't just one way of doing automation. It is the foundational principle behind pretty much every single automated factory and plant in the entire world. So I want to leave you with this question. Now that you get it, now that you understand this core conversation between the automation brain and its body, take a look around you. What's the first thing you see that you'd want to automate? What process would you tackle first?